Okay guys, welcome to this video looking at the 5 a day for CorbettMaths for Core 1. So this is explicitly for AS pure math students, so A-level math students in year 12 predominantly specifically, but it also may be appropriate for year 13s as well, and it may also overlap with the GCSE further maths course, so the AQA level 2 GCSE further maths course. It may also overlap with that, okay, and certain aspects may overlap with the GCSE syllabus, but it's predominantly aimed at year 12 students, okay. As ever guys, feel free to obviously pause the video, try and attempt all these 5 questions or the ones that you can do, and then come back and press play, and please take any notes, okay, on your notepad for today's video. Okay, so it's looking at a wide range of topics today. So the first question is looking at solving a quadratic inequality. So I'm going to try and factorize this into 2 brackets, okay, and then I'm going to put the greater than 0. Sorry guys. So 2x squared is made by doing 2x times x, okay, and then I want 2 numbers, so it's a minus here and then a plus there, so it's both going to be minuses because a minus times a minus makes a positive, and then adding 2 negatives, okay, it doesn't necessarily make a negative, but it changes the sign to a negative, okay, which means that it's highly likely the answer will be a negative, okay, but it doesn't always mean that, okay. So the factors of 21 are 1 and 21, okay, and 3 and 7, okay. So let's just test these. So this one isn't going to work at all because there's no way that I can get 13 from 21 and 1, okay. But from here I think I can. So if I put a 3 here and a 7 here, okay, it triples 2x, so the triple of 2x is minus 6x, minus 7x makes minus 13x, and then minus 7 times minus 3 is positive 21. Okay, so that does confirm my answer. Okay, so I can always check by expanding the brackets. Okay, I've done it a bit by trial and error, okay, but you would obviously test the 2 numbers, okay, and see which way around it goes in order to make that minus 13 and the positive 21. Okay, now sketching this graph, guys, so finding our solutions. Now our solutions are 7 halves and 3, so it's 3 and 3.5, so it's pretty much next to each other, okay, and then it crosses up positive 21 actually. Obviously it's a rough sketch here, okay. So let's just keep with that, but then we will just delete this and then change, oops, so change this here. So that will be 7 halves. Okay, when you solve that, and then that will be 3. Okay, 7 halves, remember, is equal to 3.5 or 3.5. Okay, for that. Now, it wants the quadratic, it wants this above 0, so it wants this above the x-axis. So this is my x-axis, guys. Sorry that it's not drawn perfectly, but it's a rough sketch. Okay, and sorry if it's not very neat, but hopefully you can forgive me for that. Okay, and this is my y-axis. Okay, so it's above the x-axis. Oops, should be an arrow there, not a tick. It's above the x-axis in this region here. Okay, so it goes on infinite many times. And it's above the x-axis here. So it's above the x-axis, okay, when x is strictly greater than 7 halves. And it's also above the x-axis when x is strictly, okay, less than 3. Okay, so these 2 points, they never actually meet here, essentially. Okay, so it's below it, okay, when x is less than 3, that's when it's above the x-axis, and it's above the x-axis when x is bigger than 3.5 or 3.5 or 7/2. Okay, and that's my answer for question number 1. Okay, question number 2, guys. It says that line L1 has the equation x plus 3y plus 1 equals 0. L2 is parallel to L1 and it passes through the point 6, 3. Or is it an 8? Sorry, I think it is an 8. Sorry, I should delete that. Yep. So it's an 8, 3. Sorry. So it's 8, 3. Now find the equation of L2. Okay, so parallel means it has the same gradient. So let's just rearrange L1 in the form y equals mx plus c to deduce what the gradient is, and then the coefficient of x will be the gradient for L2, okay, because it's the same. Okay, parallel means it has the same gradient. So taking away x and 1 from both sides, and then dividing by 3. Okay, so the gradient, imagine it's a -1 there, the gradient is the coefficient of x, so the gradient is equal to -1/3, okay, and it passes through the points 8, 3, okay. So, using this formula, which is y is equal to mx plus c, so y equals mx plus c, we know what the gradient is, and we now want to work out the c value. Well, we have a set of coordinates that it passes through. So replacing this with the number 3, okay, replacing m with -1/3, and then replacing x with 8, we're going to get -8/3 plus c. And then adding 8/3 to both sides, okay, so 3 plus 8/3. Well, 8/3 is the same as saying 2 2/3. So 2 2/3 plus 3 is equal to 5 2/3, okay? Or, as a top-heavy fraction, it would be 17/3, okay? For that. So your final answer would be y is equal to -1/3 x plus 17/3, okay? Now I could have used the formula y minus y1 is equal to m brackets x minus x1 and just rearranged it, okay? I just thought I would do it this way, yeah, because I thought, yeah, it's just slightly quicker in my eyes, okay, but you are welcome to use that other formula, okay, once you work out your gradient, okay, and then just subbing in, that's your x1, that's your y1, and then rearranging it to either make y equals a subject or in this form. It doesn't specify, so I can leave it in either form, okay, but I'll leave it in this form for the purpose of this answer, and just change that to a y, sorry. Okay, right, next question. Sketch, okay, this graph. So this is actually a cubic graph because it's got 3 different solutions. And if I expand this, I will get a cubic in the form y is equal to, in this case, like minus ax cubed, okay, plus bx squared or minus bx squared plus or minus cx plus d. Okay, so your solutions, because it is already factorized, are 3, -1 and 4. Okay, if you set y equal to 0 and you solve the equations, remember that when y equals 0, that's where it crosses on the x-axis, okay, or x-axis. So it crosses at -1, 3 and 4, okay? Now the y value, if you're interested, if I multiply these 3 numbers, -3 times 1 is minus 3 times 4 is minus 12. So it crosses the y-axis at minus 12. Okay, it's a rough sketch, guys. Okay, so a cubic graph here, it's a negative cubic here, so I've got to be a bit careful. Okay, so it is going to look something, okay, like that, guys. Okay, so it looks something like that. Okay, so that's what my negative cubic, that's my solution, minus 1, 3 and 4. Okay, for that one, guys. Okay, question number 4, we're looking at an arithmetic sequence. So in an arithmetic sequence, U6 is 20, U12 is 38. Find the common difference, find the first term. Well, it's jumping, okay, so from the 6th term to the 12th term, it's jumping 18. Okay, so if I do 18 divided by 6, that will tell me my common difference. So 18 divided by 6 is equal to 3. Okay, because it's going 6 jumps, isn't it? From 6 to 12 is going 6 terms, okay, or 6 jumps. 6 jumps represents 18, so each jump represents an increase in 3. So the common difference is 3, guys. And now I can work backwards. So U5 would be 20 take away 3, which is 17. So it'd be 17. Okay, U4 would be 14. Okay, take away 3 from 17. Okay, so 20 would go there. Okay, U3 would be equal to 11. U2 would be equal to 8. And U1, which was our first term, will be equal to 5. So the first term, guys, is equal to 5. Okay, based on my workings out here. Okay, so it goes up in increments of 3. Okay, last part, calculate the sum of the first 20 terms. Now the formula here that I have, so I have Sn, so it'd be S of 20. Okay, so it's, how many terms do I have? So I have 20 terms, and then it's the first term, okay, which is 5, plus the last term, which we have to work out and then divide our answer by 2. Okay, so U1 is equal to that, U2 is equal to that, U3 equals that, U4 equals that, U5 equals that, U6 equals that, U12 equals 38. Okay, U13 will equal to 41. U14 is equal to 44. Okay, U14. Okay, let's just put like a little line here so we're not getting confused with the previous question. Okay, so U12, U13, U14, U15 would be 47, U16 would be 50. Okay, because it's going up in 3s. Okay, U16 would have been 53. U17 will be 56. U18 would be 59. U19 would be 62. And then U20 would be 65. Okay, I've added on 3 each time, okay? So the formula is the first plus last term divided by 2. So last term is equal to 65. The first term is equal to 5. Okay, oops. Let's just delete that there. Okay. So 5 plus 65 is equal to 70. A half of 70 is 35. 35 times 20 is 700. So the sum, okay, of these first 20 terms is 700, okay? Or I could do 5 plus 8 plus 11 plus 14 plus 17 plus 20, plus 23, plus 26, plus 29, plus 32, plus 35, plus 38, plus 41, plus 44, plus 47, plus 50, plus 53, plus 56, plus 59, plus 62, plus 65, and it will indeed give you 700. Okay, so we use this formula. So the formula is S of n, so the sum to n terms is the number of terms that you are summing in total. Okay, so in this case it's 20, so it's 20 brackets, first term plus the last term in the sequence, divided by 2, okay, and then in brackets, and then that, you would obviously enter that in your calculator, okay, and that would give you your answer of 700, okay. So that's how I work out the sum to n terms of an arithmetic sequence. Okay, so this is something. Yeah, the notation here is explicitly here for like A-level students here. So it's unlikely that GCSE students have seen this sort of notation, but this is the sort of notation that we use in A-level pure maths. Okay, for looking at sequences and series. Okay, and we will build our knowledge on that in later videos. Okay, but hopefully that made sense, guys. Right, guys, that's the end of today's short, sharp video on the 5-a-day Core 1 Maths. I sincerely hope you found it useful. I hope you A-level students found it informative. If you did, please press like, please subscribe to the channel, and please click that bell icon so you are notified, okay, of when I upload on this channel for GCSE Maths and AS and A2 level pure maths, okay, as well as Key Stage 3 and the occasional Key Stage 2 video as well. Okay, but thank you so much for watching. Any questions, any topic requests for A-level pure maths, then put it in the comment section. Thank you so much for watching, and I'll see you all inside the next video. Okay, bye bye for now.